This is the mathematics of the calendar, presented by Daniel Martignetti and Shayn Horrocks.
The types of calendars. There are many different types of calendars, including solar, lunisolar, lunar, seasonal, and fixed. They all are based on different natural events or a set amount of time.
Lunar, solar, and lunisolar. Solar calendars are the type of calendars that we use today, based on the Earth's rotation around the Sun. A lunar calendar is based off the Moon's rotation around the Earth, with 1 month being one full rotation of the Moon. A lunar-solar calendar is based off both the solar and the lunar cycles, with adjustments made to the length of the months and years.
Seasonal calendars. Seasonal calendars aren't meant for use of telling time as much so as they are used for information. A seasonal calendar compares time to another factor, which can be adjusted for different uses. Meteorologists can use rainfall, storms, or snowfall. Marketers can use number of tourists, dollars spent, or amount of shopping. Or farmers can use crop yield as the dependent variable to receive valuable information from the seasonal calendar.
This is an example of a seasonal calendar showing the best times to harvest different fruits and vegetables during the year.
Fixed calendars. The fixed calendar came from a man named Moses Cotsworth. He was a Northeastern Railway advisor. He noticed that since the months are different lengths, earnings varied from month to month. The fixed calendar sports 13 months, 28 days each, and one extra day called Year Day. This appeals to businessmen or people in transportation for the sake of time consistency.
This is an example of the fixed calendar. Leap years.
Leap years. A leap year is when an extra day is added onto a year, making the year consist of 366 days. This day is February 29th.
Why we have the leap year. One cycle around the sun amounts to approximately 365.25 days. If the quarter of a day is skipped, then every 4 years the calendar will be behind by 1 day. To make up for this, every year that is divisible by 4 is a leap year, and an additional day is added every year that is divisible by 400.
Tropical year is showing one actual year, common year is showing one calendar year, and leap year is showing one calendar leap year.
Friday the 13th.
Friday the 13th. For years, Friday the 13th has been considered a day of bad luck and danger. Every year has at least one Friday the 13th. But why?
History. On Friday, October 13th, King Philip IV had over 60 Knights Templar arrested, tortured, and killed. Ever since then, Friday was considered evil by anyone involved or supporting the Knights Templar. The Knights Templar are a mysterious organization from the 1300s, better explained in the Da Vinci Code movie series. It could also be traced back to Jesus' Last Supper, where 13 people attended the meal.
Superstitions. There are many superstitions based on Friday the 13th, including the number 13 is unlucky. If 13 people eat at a table, one will die the next year. Some tall buildings skip the 13th floor. Some streets skip house 13. Some airplanes skip row 13. Some theaters skip row 13. Apollo 13 malfunctioned at 1313 military time. There is no number 13 Formula 1 car.
Mathematics of Friday the 13th. If any Mondays start with a Sunday, then there will be a Friday the 13th. To find the maximum amount of Friday the 13th, you must first see how many months start in the same weekday. An example is February and March. The maximum is 3 months that start on the same weekday, so the most possible amounts of Friday the 13th is 3. The average number of Friday the 13th can be computed by dividing the number of months by the number of days in a week. This is 12 divided by 7, which equals approximately 1.7 Friday the 13th. Calculations.
Calculations. There are different ways to use calculations to find the exact weekday of any date.
Zeller's rule. The formula for Zeller's rule is F equals K plus bracket parentheses 13 times M minus 1 parentheses divided by 5 bracket plus D plus bracket D divided by 4 bracket plus bracket C divided by 4 bracket minus 2C. K equals the date, M equals the month number, parentheses, starting at March and ending at February, going 1 to 12, parentheses. D equals last 2 years digits of the year, using last year for January and February. C equals the first 2 digits of the century. The answer will come out to a number between 0 and 7, corresponding to a day of the week. 1 equals Monday, 2 equals Tuesday, 3 equals Wednesday, 4 equals Thursday, 5 equals Friday, 6 equals Saturday, 7 or 0 equals Sunday.
Key value method. The key value method uses codes to speed up calculations. First, take the last 2 digits of the year and divide them by 4, and drop the remainder. Then add the day of the month. Then add the key value for the corresponding month. January equals 1, February equals 4, March equals 4, April equals 0, May equals 2, June equals 5, July equals 0, August equals 3, September equals 6, October equals 1, November equals 4, and December equals 6. If the date is in January or February of a leap year, subtract 1. Then add the century code. 1700s equals 4, 1800s equals 2, 1900s equals 0, 2000s equals 6. Add the last 2 digits of the year, divide by 7, and take the remainder. 1 equals Sunday, 2 equals Monday, 3 equals Tuesday, 4 equals Wednesday, 5 equals Thursday, 6 equals Friday, and 7 equals Saturday.
Gregorian versus Julian calendars. Gregorian versus Julian calendars. The Gregorian calendar and the Julian calendar are 2 different types of calendars used in the past, established by different civilizations and have varied use today.
Gregorian history. The Gregorian calendar is the calendar that is in use today in most parts of the world, excluding the Jewish calendar, the Islamic calendar, and the Chinese calendar. During the 1500s, the Roman Catholic Church discovered that the Julian calendar was slightly off, causing Easter and other important religious events to be miscalculated. Pope Gregory XIII issued revisions to the Julian calendar in 1582, which became known as the Gregorian calendar.
This is what the first Gregorian calendar looked like, and Pope Gregory XIII. Mathematics. 1 minute equals 60 seconds. 1 hour equals 60 minutes. We got that from the Mesopotamians. 1 day equals 24 hours. We got that from the Egyptians. 1 week equals 7 days. We got that from the Jewish calendar. 1 year equals 365.242199 days. There is a leap year every year that is divisible by 4, and every year that is divisible by 400.
Julian history. The Julian calendar was established under Julius Caesar in Rome during the year of 46 BC. The calendar was derived from a mix of Babylonian calendars, Mesopotamian calendars, Egyptian calendars, and Jewish calendars. The calendar was designed to benefit farmers by using the solar cycle, since Rome was largely agricultural at the time.
This is the Julian day calendar. Mathematics. 1 minute equals 60 seconds, and 1 hour equals 60 minutes. 1 day equals 24 hours, 1 week equals 7 days, just like the Gregorian calendar. But instead, 1 year equals 365.25 days, and there's a leap year every year that is divisible by 4, and a leap year every year that is divisible by 100 instead of 400.
Comparison. The Gregorian is an example of a lunar-solar calendar, with the years derived from the solar cycle and the months derived from the lunar cycle. While the Julian calendar is based on the solar cycle, the Julian cycle was estimated every year to be exactly 365.25 years, when in actuality, it is only 365.242199, meaning every 129 years the calendar became 1 day off. The Gregorian fixed this mistake by adjusting the frequency of leap years.
This shows the difference between the Gregorian and the Julian years. Bada bing, bada boom, we done. Tab. 1 leap year every year divisible. Well, there's a leap year. We didn't change.
Since Rome was largely architectural, cycle estimated is comparison.
This shows how the difference in the amount of time that day